Hi, welcome to Accuracy, Precision, and Percent Error. These are really going to be entailing some of our measurements and lab activities that we're going to utilize throughout the year. Accurate means you're close to the actual value of what you're trying to measure. So in the idea here that if one Oreo's mass is really 15 grams, and I do my measurements on some old triple beam balance, and mine is 14 grams, that is pretty accurate. Accurate, though, as we can see, is qualitative. Meaning, yeah, it looks close, it seems pretty accurate. However, there is no definitive range of accuracy. In college, you might hear, 5%'s good. Other colleges might say 3% is where you would say it's accurate. But those are all determined by the teacher or the situation. There's nothing here to say how accurate things are. There's just this general idea that, yeah, it's pretty dang close. Such like if this was a 12-ounce bag of coffee, as it's labeled, but I measure it as 16 ounces, well, that's not very accurate. Now you might say, how do I know? Well, you're comparing the numbers, aren't you? We'll get to the quantitative part, what's called percent error, in a little bit. For example, also, your idea of this tire, if it's 21.3 pounds, and I say, oh, it's 25 pounds, oops, let's undo those, 25 pounds for mine, I would also call that not very accurate. Again, though, this is a qualitative look at seeing if it's close to the actual value. So let's take a look at what precise means. It can mean two things. So we'll use it often one way, but we'll often see it in both ways in lab. So it can mean all of your attempts are close together or more decimal places to the measurement. So for example, in our Oreo, if I had three measurements, 15 grams, 19 grams, and 10 grams, I would say those are not very precise. They have a big range from 19 to 10, not very precise. If I look over at the idea of my coffee and I have 12 ounces, 11 ounces, and 13 ounces, I might say that's actually pretty precise. It really depends on how much I want to describe my precision, or even in the fact of having it be one way or another close together. We know what's my outside range? That's kind of up to the experimenter and even the situation. Such like if I have my tire and I get 21.3 pounds, 29.41 pounds, and 20.01 pounds, I might see those as those are pretty far apart. That is also not very precise. So that is the concept of precision when it comes to being grouped close together. The other one happens to be with the idea of how many decimal places there are. So when I look back at my Oreo, these would be measured on a very low precision scale. It only measures to the ones place. This would be something you'd find in your kitchen scale, probably run you about $15 on Amazon. If you have a scale like this, 15.000 grams, you would have to buy that at a specialty store, not on like Amazon, and probably run you about $300 because the level of precision is to the thousandths place. So this measurement is more precise than any one of those three measurements. So we see we have this idea of precision. It's still qualitative, but it's comparative. Such like, such like if we have our coffee here, and I measured it on my same exact scale, and I got 12.010 grams, or I should say not grams, ounces. that the idea is that this is a more precise measurement than any one of these three. And it might even be the same measurement from here, only I put it on a different scale, so I got a slightly different, more precise value. Same holds true for my tire here. If I put this time when I measured it and put it on the other scale, and I got 21.3090 pounds. A more precise measurement than any one of those three, because it goes to 4 decimal places while the maximum is just 2. So when we think of precision, we could talk about a group of data being precise or not precise, and we can talk about a measurement, singular, being precise or not precise. We can always improve the precision of any measurement by putting it on a more precise scale. You really need to get down, especially in explaining the difference between precise and accurate. Okay, they're both qualitative, but they're talking about two different things. Okay, both qualitative, but two different things. All right, now let's look at percent error. This is a quantitative look. This is a quantitative look of how well or how close we got to a true value. You'll have this equation to use. Again, chemistry is not a whole bunch about memorization. It's about taking in knowledge and then using that knowledge in many different situations. So let's take a look at how to do that. Alright, so here's our example, determining density for silver. You got your true value and your other values. What is your percent error? So your percent error is found here, experimental minus the accepted all over the accepted. You can have a positive or negative percent error. That just tells you if your value was larger or smaller than the value accepted, which can be important if you're trying to minimize and lower the overall amount of percent error. So we're going to start off with our experimental value, and that would be 6.35. You always put the units. There is no numbers without units. Minus our actual value all over our actual value times 100%. So when we have this and we do our subtraction, we're going to see that this is equal to a negative 4.2 grams per milliliter, same units, all over my 10.5 grams per milliliter. And again, this is still going to be times 100%. So we need to do this because these have what's called significant figures. They haven't been mentioned yet. Common decimal place when subtraction is to the tenths. So you should always write what that subtraction is so you can see the decimal places in order to determine significant figures. When we divide, that's 10.5, it's the lowest amount of significant figures. Again, we'll cover this in a future lecture. And so when I have this divided by 10.5 times 100%, I get a negative 40, and this would be with a decimal, percent. So don't worry too much about sig figs for now. Get the practice down. When you learn about sig figs, you'll incorporate this every time you do this type of calculation. All right, now it is your turn. Answer the question on Edpuzzle and then see how it's done. You should always view how it's done, even if you got the same answer, because I'm expecting you to do it the way I taught you and no other way. So you want to make sure that you have this correctly done as you have it going forward. All right, so here, let's look at the solution here. So 6.35 meters minus 6.37 meters all over 6.37 meters. This will be times 100%. So that'll be negative 0.02 meters all over my 6.37 meters. You see that the same units on top and bottom, it will go away It'll be canceled out. That's why we're left with just a percent. Kind of percent is your unit. And so then I will get negative 0.3%. A fairly accurate measurement, if I do say so myself. While the previous one at negative 40%, not very accurate. Both are quite precise because they were measured to the hundredth of a gram, or hundredth of a gram per milliliter. I should say meter, or gram per milliliter. So again, when we think of this idea of precision and accuracy, those terms are kind of qualitative, up to interpretation, but the percent error can really see how far or close we were to our true measurement. Please sure to come in with any of your questions, and I'll see you soon.